Assalamu alaikum, dear students. In this lecture, we will be discussing the empty set. We will be discussing finite and infinite sets and equal sets. Moreover, we will solve the exercise that's based on these concepts. That's exercise number 1.2. You all open your books and go to exercise number 1.2. Before going to exercise number 1.2, let's recall that empty set is a set having no element. In empty set, we have no element. Empty set is represented by a Greek letter phi that you can see. I will be highlighting here. So this empty set is also called null set or void set. Its representation is with the help of this Greek letter phi or simply these braces. Here we have some examples. For example, a is equal to x such that x lies between 1 and 2 and x is a natural number. Since we have no natural number between 1 and 2, just after 1 comes natural number 2. So between 1 and 2 is no natural number. But this statement is valid mathematically and it has no element. So it is a null set, void set, or empty set. Let's come to the concept of finite and infinite sets. A set having finitely many elements is called a finite set. For example, we have here is set A. It has elements 1, 2, 3, 4, and 5. Set B, it has elements A, B, C, D, E, F, and G. So these are both finite sets. However, for infinite set, we have infinitely many elements. For example, we have set of natural numbers, set of integers, set of rational numbers, set of real numbers. These are all infinite sets. Next concept that's here, that's equal sets. Two sets are said to be equal if they have exactly same elements. Here's the definition I would like to highlight here. We write equal sets A equal to B for any two sets A and B. Whereas if the sets are not equal, they're called unequal sets, and we write the symbol A is not equal to B. So what is in case of equal sets, every element of set A is in set B and every element of set B is in set A. So let's go to the exercise number 1.2. To solve this exercise, let's move to the question number 1. In this question, we are asked here, which of the following are examples of null set? The first part is set of odd natural numbers, so divisible by 2. So we will check first of all odd natural numbers. So what are they? Let me go to the solutions I have written here. The odd natural numbers, you know, they are 1, 3, 5, 7, dash and dash. And among these, which one is divisible by 2? You know, one is not divisible by 2. 3 is not divisible by 2. So dash and dash. A set of odd natural number divisible by 2 has no element, so it's a null set. Next one is the next part of this question, that is set of even prime numbers. You know, even numbers start from 2, 4, 6 dash and. So even prime and prime numbers, you know, the set of prime numbers is like this: 2, 3, 5, 7. So the common element between these two is 2. So this set has at least one element, and in fact only one element, that's 2. So it's not an empty set. On the same lines, you can solve these two parts as well. Let's go to the question number 2. Which of the following are finite or infinite sets? So the first part is the set of months of a year. The set of months of a year. Months of year, you know, they are 12 in number and you can enlist them. It's a finite set. Next part number second, it is here. You can see it. It's 1, 2, 3. Then after there are dots. That means this set continues. There is no termination to this elements of the set. So it goes on. So we can say that this set has no end. That means this set is an infinite set. After that, this is part number third. We have elements. It's 1, 2, 3. Thereafter, there are also dot, and there's continuity. And seen here, it's 99 and 100. That means in this set, the elements go from 1 to 100. So if they go from 1 to 100, there is a finite end to this set. So this set is a finite set. It has 100 elements. The set of positive integers greater than 100. Greater than 100 positive integers. You have to start from 101. Up to what end you have to go? There's no end. This set has no last end. So we can say that this set is an infinite set. The set of prime numbers less than 99, you know, starting from 2, 2, 3, 5, 7, dash 1 dash, and you can check what is the last prime number below 99. So this set has finitely many elements. Next is question number 3. In question number 3, we are asked, state whether each of the following sets is infinite or finite or infinite. To solve this question, we have part number first, the set of lines which are parallel to the x-axis. So, which are parallel to x-axis. I will be plotting here. So, this is xy plane, this is x-axis, and this is y-axis. So we have to draw the lines parallel to x-axis. These are lines. How many lines can we draw? We can draw infinitely many lines above and below that are parallel to x-axis. So we can say there are infinitely many lines that are parallel to x-axis. So it is not a finite set, it is an infinite set. The set of letters in English alphabet. So you know there are 26 in number, so therefore it is finite set. The set of numbers which are multiple 5. Multiples of 5, you start from 5, 10, 15, 20, up to what end you can go. So there is no end. Therefore, this set is an infinite set. The set of animals living on the earth, it's a finite set. Although the uh, count of the animals on the earth is very large, so this is a finite set, not an infinite set. After that, we have next question, that is the set of circles passing through the origin. So set of circles passing through the origin. To understand this, let's once again plot xy plane. Here is the origin. So we will be, this is 0 0. So we have to draw the circles. They should pass through this origin. This is one such circle. This is next such circle, and this is next such circle. Sorry. So the next is, in this way you can draw any number of circles which pass through the origin. So it's an infinite set. So what is next? Let's move to the next question. And the next question is, in the following, state whether A is equal to B or not. We have to use the definition of the equal sets. We have A is equal to ABCD and B is equal to DCBA. Let's see, in set A, we have element A, that's in B. We have element B, that's in set B. We have element C, that's in set B. We have element D, that's in set B. And also, if we check whether all the elements of set B are in set A, yes, that is, D is in A, C is in A, B is in A, and all these elements are here in A. That means I would like to once again utter these words. All the elements of set A are found in set B, and all the elements of set B are found in set A. So we say A and B have exactly same elements, therefore A is equal to B. What about this part number second? Here we have elements 4, 8, 12, and 16. 4 is here, yes, 4 is here. 8 is here, yes, 8 is here. 12 is here, 12 is not here. So there's element 12, that's in A, but that's not in B. Therefore, A and B are not equal sets. Similarly, you can do these two parts. Next is question number 5. In question number 5, we are asked here, to are the following pairs of sets equal or not? Once again, the question is same, tune is different. A is equal to 2, 3. B is equal to x such that x is a solution of x squared plus 5x plus 6. If we want to solve this equation and we want to find the elements of set B, let's check what are the elements of set B. See here, B is this equation. We will solve this equation by splitting the middle term, and we will get the solution, the values of x as -2 and -3. Obviously, A has elements 2 and 3, but B has elements -2 and -3. So these are not equal. Next part, that is, we have two sets. Set A, x such that x is a letter in follow, and y such that y is a letter in above. If we want to write the elements of this set A, we have to write the elements, but note that we will not be repeating as per the rules of the sets. So what are these? We have to write like this: F, O, L, W. Why? Because we will not be repeating the elements. Next is B. It's W, O, L, F. Yes. You see, here we have four elements. We have four elements. And all the four elements of set A are the four elements of set B. And all the elements of set B are also the elements of set A. Therefore, A and B are equal sets. After that, we will go to question number 6. From the sets given below, select equal sets. Once again, the definition is same, and you will apply, you will check whether and which of the sets have equal elements. For example, we have set A. You will check which one of these set has elements 2, 4, 8, 12. If any of the set is there that has elements this, then A is equal to that. So this is a home assignment for you. Hope that in this lecture you have got very well. If you have any queries, you can ask me in the group. Thank you for being in the class.